must have gone to some amusement parks, right? You must have seen this sort of flashing lights over there, like these fountains. But do you wonder what are these fountains? Why are the water coming out of it colored? Like, you must know that this is not a colored water, right? Because in morning when you see the same fountain, it's like a normal beam of water that is like transparent in color. But at night it glows like it is of pink color, red color and all the changing colors. But like you must have seen in earlier classes that light travels in a straight line. So whenever the fountain is there, like it changes, the water changes its direction. Why does the light change its direction as well? Like, why are you seeing the light changing its direction along with water? Light should travel in a straight line, right? It should not bend away, because in all the earlier videos we have been saying light travels in a straight line. So to get a clearer picture of this, let's perform some activities and try to really get into the fact that why light bends. Like, what is it that is making the light to bend along the water? So this is to demonstrate what you were seeing earlier in the fountains. So what actually was happening, like I am having the replica of this, I am having this bottle filled with water and I am having a little hole in this, like you can see. So the water is just spilling it out. So now what I'll be doing is I am having a laser torch. I am having this laser torch and I'll be just releasing this torch. I'll be just switching it on exactly at a point exactly behind this hole. So let's see what happens. So here is it. So you can observe that the light is bending. So this is it. You can observe the light is bending. So this is basically because of total internal reflection. So let's see into a little detail with the help of this teaching aid. Earlier videos we have been saying continuously that light travels in a straight line, it travels exactly in the straight line. But like seeing the earlier two videos, aren't you amazed why does light travel in a straight line? Like in exactly the last video I showed you that the light was exactly bending when I showed the laser torch. But why was it bending? Like continuously we have been saying it travels in a straight line. So there needs to be a reason behind it, right? So let's see a little clearer picture of that, what was actually happening. So I have this empty glass. I'll be filling it half with water. Like this. Now to make it a little translucent sort of solution, I'll be adding a little Dettol into it. Like this. So now what I'll be doing is I'll be passing this laser beam through it, but before that I want to see this is what we call reflection, like it is reflecting back, but there needs to be some sort of refraction as well, right? Like we say when there is change in refractive index, so the refraction takes place. So to demonstrate refraction, what we'll be doing is I'll be just simply spreading this incense stick, this agarbatti over this, just to make it a little cloudy sort of thing. So now I have filled this above portion with the smoke and the lower portion is with water, added a little Dettol over it. So now what I'll be doing is I'll be passing this laser beam. So now you can see you can see two things happening over here. One thing you can see is a little sort of scattered light above the water. That is because of refraction, right? And there is another beam of light, this one that you can see. This is basically because of reflection. This water layer is acting as a reflecting medium. So now I'll change this angle and you just observe the scattered light and the light that is reflected back. So with the increasing angle, what you can see is at certain angle the scattering is minimum. Like you can observe that there is no scattering, it's just internally reflecting back. So this particular angle where the refraction is not taking place but just the reflection is taking place is what we call the critical angle. So whenever the angle is critical angle or more than that, the total internal reflection will take place. So this phenomena is what we call TIR, that is total internal reflection. That is, in a medium, every light will be reflected back into its own medium other than refracting back. So let's get into a detailed theory part of this. So this was the glass. Let's assume this was our glass, and we filled it with water, right? This was the water, and what we did is there were a little air particles, like we made it into a translucent sort of solution and we covered it with a lid. So now what I was doing is I took a laser. This was suppose my laser, and this was the laser beam. So what was happening, like let's recall from the earlier activities. What is this? This is water. And what is this? This is air. So this is a denser medium, this is a rarer medium. So whenever a light passes from denser to rarer or vice versa, it must change its direction, like there will be reflection, right? So otherwise it would have gone into a straight line, but since it is from denser medium to rarer medium, it will bend away from the normal, like this, correct? But the other thing is, you must have gone on a sunny day, like to a beach or to a lake, and you must have seen your image in the water, right? But how do you see the image in the water? That justifies that water can act as a mirror as well. Like you must have seen some animals sing in the water, they see their reflection. So water can act as a reflecting surface as well. So for this particular ray, this particular top layer of the water can act as a mirror. Like you see the mirror. So as it is a mirror, it reflects back, so light will reflect back also, correct? So these two situations will happen. So what you are observing here is refraction and reflection are taking place simultaneously, but we said that this will deviate away from the normal, and this angle, like this is a reflection case, so if this is angle I, this is angle R, so angle I is equal to angle R, it will bend in such a way. So now what I'll be doing in the other cases, what I did is I changed this angle, right? So suppose, I'll do it with this one. Suppose if the ray was like this, if I change this angle of this laser, if the laser was like this, so now what will be happening is, this is the normal, it will bend away from the normal, right? So it will bend like this. You can see the change in angle, and like this, angle I, angle R, this will happen. So finally what I did is, in one of the case, what happens is, you can see the refracted ray is bending, like it is bending towards this water layer. So at a certain angle, what happens is, this refracted ray just compensates to an angle that it is flat. It mixes with the water surface and it is no longer reflecting in the air. And the reflected ray is anyways there. So this particular angle, this angle, where it actually bends into the water, where no refraction is taking place, just the reflection is taking place. This angle is what we call the critical angle. So now you can see this particular angle, this angle that I have marked like this angle, this is what we call theta c, that is a critical angle. So you can see this critical angle is the case when this refracted angle is 90 degree. Like theta c is called the critical angle when everything is in reflection, like no ray is reflecting back, or we can say the refracted angle is 90 degree, because like after theta c, let's see if in another case what will happen is, the complete light will simply bounce back into the water, no light will go in the air, right? So this is the case where total internal reflection is taking place.